Go and open your book to page 400. Today's lesson is learn how to find the equation of the hyperbola. So last time we looked at ellipse. Now hyperbola is like an ellipse turned inside out. So this is ellipse. If you turn it inside out, the hyperbola will be like this. Okay. Now for ellipse, the sum of focal radii equal to 2a. So for ellipse, right, it's any point, the sum will equal to 2a, right? That's a d1 plus d2. Now over here, it's kind of the opposite. So any point, like if you pick a point over here, okay, so this is d1, d2. In this case, d1 minus d2 equal to 2a. Over here, the ellipse is d1 plus d2 equal to 2a. So this is like d1, d2, right? So hyperbola is minus, and the ellipse is plus. So just like the ellipse got turned inside out. Other than that, everything else kind of stayed pretty much the same. Now, for ellipse, with a center on the origin, this one, the center is over here. So the center, when the center is at origin, you're going to get x squared over a squared plus y squared over b squared equal to 1. For hyperbola, it's going to be minus. So if this is the x direction, then x comes first. So it'll be x squared over a squared minus y squared over b squared equal to 1. Okay, so ellipse, you get plus, hyperbola, you get minus. Now, if you have y squared over a squared minus y squared over b squared equal to 1, x squared. So whichever letter comes first, that would be direction of the hyperbola. So like this one, if it's open to the x direction, that's when x comes first. For this kind of situation, the y comes first, then you're going to have hyperbola going this direction. Okay. So this is when y comes first. This is when x comes first. Okay. Now, for ellipse, right, because it's addition, so it's commutable, so you always put an x squared first. So the direction of this determined by the a. So if a is under the x, then the long will go under the x. So if you have an x squared over b squared plus y squared over a squared equal to 1. So when a squared is under the y, then this will go in this way. Okay? So notice for the ellipse, you switch in the a and the b. Okay? And the direction determined by the a. So whichever a is under, and that's the direction. So if a is under the x, then the long will go in the x direction. Over here, when the a is under the y, then it goes in the y direction. Okay? So for ellipse, it's determined by a and the b, and the a and the b switch. The x and the y stays. Now over here, the a and the b stays. See, a always see a and b, right, stays. The one that switch is x and the y. So x comes first, then the graph will go in the x direction. If the y comes first, it will go in the y direction. Okay, and also over here, in this case, your c is the biggest number if you use your Pythagorean theorem. So in this case, you're going to get b squared plus c squared equal to a squared, right, for ellipse. Okay, so this is kind of a bit weird. But for hyperbola, everything is normal. This one you get a squared plus b squared equal to c squared. So c is the biggest number. Okay. So the c, so the a, again, a is always from the center to, a is always from the center to the vertex. So over here, the a is right over here. So this is the a right over here. So from the center to the vertex, that's the a. The c is from the center to the focus. So over here, that is the c. So same thing, the definition are the same, right? From here, from the center to vertex, right? Here's the vertex, here's your center, right? So here's your a, right? A is from the center to the vertex. Over here, a is from the center to the vertex, okay? The c is from the center to the focus, so your c is right over here. That's a c right over here. Over here, the C is from the center to the focus. So in this case, you see that C is bigger than A, and that's why you have this kind of situation, right? Over here, the A is bigger than C, and that's why you have this situation, right? Okay. So you kind of a little bit comparison. Okay. So now let's go over how to do some of the problems. So whatever you do with ellipse, you're going to do the same way. Okay. So just do the same thing. So let's go to example 1. So you have a hyperbola, so you got y squared equal to 3x squared plus 12. Okay, and it says graph the hyperbola, show its asymptotes. I will explain what asymptote is. Okay, it's dash line and its foci. Okay, so again, first you need to put in a standard form. So you need to move all the variable to one side. Now you always put a positive on, in the beginning. So right away you know that this graph is going to open in the y direction. Okay, your next step is you have to divide by 12. Right? You have to make it equal to 1. Right? That's your standard form. So divide by 12, just like ellipse. So you got y squared over 12 minus x squared over 4 equal to 1. Okay, so now you're going to ready to graph. Now when you graph the hyperbola, first what you want to do is you want to draw the box. Okay. So over here you got a squared equal to 12. So a equal to square root of 12. So a equal to 2 square root of 3. Okay. Okay. Now when you graph this, so you know this is going to be in y direction, right? So 2 square root of 3 is about 3.4, about 3.5. So it's about right over here. Okay, you can use calculator to figure it out. Okay, and you have to go in both directions. So basically, what you need to do is you have to draw the box first. So you go up, so negative 3.5. Okay, and then you have to go in the x direction. X direction, you got b squared equal to 4. So b equal to 2, right? So you go. So first you need to do is draw a box. A very light box. Okay. And then after that, you're going to connect the corner of the rectangle box, and you're going to draw the dash line. Okay. This is called the asymptotes. The dash line, your asymptote. Those are like your boundaries. Okay. Imagine like this is like imagine that this is like in a movie Jurassic Park. You have those high voltage, fence, right, to separate different regions. You're not allowed to touch, right? If you touch it, you get zapped, you die, right? So these are like off limits. So your graph are not allowed to touch the asymptotes, okay? And so now, the point over here that you get on this box over here, that is your vertex. So your graph is going to go like this, and now, you have to be careful with your graph. Make sure it does not touch the asymptotes. If you touch the asymptotes, you lose points, you die. Okay? So do not touch the asymptotes. Okay? And again, your graph, you want to get closer to the graph. Do not curve back. Okay? If you do this, you're going to lose points. If you graph like this, then you're going to lose points. Cannot do that. Okay? So asymptotes is like your limits. You want to get closer and closer to the graph without touching it. Okay, so when you're doing the graph, you want to get closer and closer to the asymptotes without touching it. So that is your graph, and then you have to find the foci, right? You want to find the focus up here and focus down here. Now you have to label you have to know how to label. So vertex, you have to use the exact numbers. So it'd be 3, 2 square root of 3. And this vertex over here would be 0, negative 2 square root of 3. Okay, use the distance. Now you have to find the f. So you have to use the Pythagorean Theorem. So a squared plus b squared equal to c squared. So you got 12 plus 4 equal to c squared. So 16 equal to c squared, so c equal to 4. Okay, so here would be your focus. The focus would be at 4. And if you label, it would be 0, 4. If you label, it would be 0, negative 4. Okay, use your Pythagorean theorem. Right, again, here's your center. So the center, now don't use C for center because the C is over here. C is the distance. So you want to write out the whole word. So center is a 0, 0. Okay, and that's it. So again, the dashed lines are your asymptotes. So when you're doing the graphing, make sure you draw the box and then you draw the dashed lines. Okay, now let's go to example 2. So this one, they give you equation, you have to graph. Next one, they give you information, you want to sketch it out to get the equation. So page 403, example 2. It's a found equation of hyperbola having 4 sides at 4, so 4 sides at 4, comma 0, and negative 4, 0. And the difference of the focal radii equal to 6. So that means 2a equal to 6, right? The difference of focal radii. In the ellipse, it's sum of the focal radii, right? But it's the same thing, it's 2a. Okay, so exactly the same thing. Okay, so let's go and sketch these things out. Okay, so 4, 4, comma 0. So you go 1, 2, 3, 4. So that's the F. And then you go 1, 2, 3, 4. By the way, from here we can see a equal to 3, right? Okay. Okay, so that's F. So right away the center is going to be over here. Now from here you can see that this is going in the x direction. So right away you're going to get x squared minus the y squared equal to 1. Okay, so right away you want to get your format. Go and get your format. Okay, once you figure out the direction, this is going to be in x direction, so x comes first. So if x comes first, y will go over there, right? So now you have to figure out this number over here. Now it tells you a equal to 3. Now a is always same direction as f, so a is over here. So you know that graph is going to go something like this. Okay, so a equal to 3, so we know that it's going to be equal to 9 because this is an x direction. So now we have to figure out this number over here. So from here we can see, by looking at this picture, we can see that, so this is your A. So A equal to 3, and this is your C, right? So C equal to 4. So we can go and figure out the B. So use your Pythagorean theorem. So A squared plus B squared equal to C squared. So you're going to get 9 plus B squared equal to 16. And so B squared equal to 7. Now you don't have to solve for B, right? This is the B squared, so it'll be 7. Now if you want to graph, it doesn't ask you for it, but if you need to graph, this is what you do, solve for it, right? And so square root of 7 is about what, 2 point something, okay? So now B is going to be in the y direction, so you go 1, 2, 3. So it's about over here. Okay, so you go ahead and draw your box. Again, when you graph, you always draw your box first, and then you do the asymptotes. And then graph will go like that, go like this. Now, the graph always go through the vertex, right? So make sure you always go through the vertex. And so that would be the graph. Okay. And that would be example 2. Okay, so you need to know how to do either way. Okay, so let's go and do some practice.
Oh, you need to get your own graph paper.